Section 5.5, Loans. Goal in this section, be able to solve applied problems involving loan payment formula. So in the previous section, we saw regular periodic payments into a compound interest-bearing account can grow your savings. In this section, we're going to look at the other side of the story. Banks and loan companies use the same basic concept to make money off of home loans, car loans, student loans, credit card balances, etc. Pretty much you name it. If you're borrowing money, they're using something similar to what we're going to see in this section to figure out how much you're going to have to pay them so that they can realize a certain goal in the future. So the formula we're going to use is the loan payment formula, and more importantly, this is the one you're going to use to find the payments. And that's really the form that you're going to be seeing for, the homework and everything else. So this other one, it's equivalent, but you don't really use it for what we're going to do. The P in this case is the present value, the principal. This is the amount borrowed. So whatever you're borrowing is the principal. The PMT is the payment, just like it was back in 5.4. It's what you're paying on a regular basis. So it's going to be the same amount at regular intervals, just like what we saw in the savings plan. The R is, as usual, the annual percentage rate changed to a decimal, T, number of years, and the number of payments made per year. And the thing to keep in mind is that N and PMT, the payment, they're going to be at the same intervals, the same periods. So if you're paying monthly, then you're compounding monthly. This number of payments made per year, you can also think of this as the amount it's compounding. I did do a video that goes through the derivation of this formula. If you're interested, it's an optional thing, but just make sure that you are aware of it. And if you do want to see where the formula comes from, I went ahead and did it in there. But otherwise, we're just going to go ahead and use this. What I will point out is that it does have similarities to the savings plan formula. In fact, if you watch the derivation, you'll see the savings plan formula is a part of it. But there's some other adjustments that have been made to get it to be distinct in its own right when you compare it to the savings plan. So in this case, whenever you are looking to solve for a loan payment, you'll be using that formula. And because the formula is based on compound interest, you are not only paying back the principal, but interest on the principal. It's important to remember. The loan company will always take the interest first. This is why in home loans, if you look at how the payments are broken down, if you're paying $1,000, probably around $700 of that in the first payment is going to go towards interest. They just take their cut right off the top right away, and then whatever little bit is left goes to the principal. So they always take the interest before paying down the principal. And that's why, if anybody is ever getting a loan out there, they recommend that if you can, pay down the principal early so that you reduce the amount of interest you have to pay in the long run. But we won't get into that too much here. You'll see that in the Excel assignment that I've done, put together for you. But for the most part here, it's going to be just finding the payments and then doing some things around that concept. So in this example, might want to go ahead and try it first as usual, but I'm going to go ahead and just start diving in. So the Warwicks are planning to buy a house. The list price is $375,000. They can get an annual interest rate of 3% on a 30-year loan if they put 20% down. So how much is the down payment? And you need to figure this out first. I'm just going to say it's D. So the down payment is going to be 20% of this $375,000, which means you're going to multiply 75, sorry. There we go. And when you multiply that, you get $75,000 as the down payment. How much do they have to borrow? Well, the borrowed amount is going to be the list price minus the down payment. So the principal is really what you're borrowing. This is, in the formula, that is the principal. So it's going to be the list price minus the down payment. Because when you pay things down or you put money down, you're not going to pay interest on that. You're giving that to the bank right up front or the loan company in order to avoid paying interest on it in the future. So the amount you're actually borrowing that you need to get from the bank or loan company is $300,000. All right, so now what is the monthly payment to pay off the principal? And in this problem, some of the key words here, you see loan right there. It's like, ooh, is it a savings? No, it's not. It's borrowing, so it's going to be the loan payment. And if they say something with a loan with simple interest, the word simple interest always overrides everything. If you see simple interest, you use that formula from way back in 5.2. But with the word loan, no mention of simple interest, you're going to use the loan formula. So you go ahead and get that down here. This PMT equals P times R over N, all over this parentheses 1 minus another parentheses 1 plus R over N, and then raised to the negative N times T power. So we need some pieces here, and we have the principal right here. We figured that out. We're borrowing $300,000, so we'll start that out there. And then I need R and N. So the R given is 3%. We need to convert that to 0.03. And then the monthly payment right here given, that means that N is going to be 12. And then the 30-year loan, so there's the T up in the original statement. So I got all the pieces now, so we'll just put this 0.03 R over the N, which is 12. Then divide this by 1 minus this 1 plus 0.03 over 12 raised to the negative 12 times 30 power. And if you're putting this into a calculator, make sure you get all the parentheses. The negative is actually at the bottom of the keyboard on the TIs. It's at the bottom of the keypad where you see all the numbers. You don't use the subtraction that's over on one of the sides. You have to use the little negative in the calculator. But also in the calculator, make sure you put parentheses around everything, just like I got here. Now in Desmos, you don't have to worry so much, but you'll be able to see, and it should look just like this when you type in a Desmos, and I'll show you that here in a second. So we're just going to type in 300,000 parentheses 0.03 divided by 12, right shift or right arrow to get out from under there, and then oops, you don't want that. I want to do divided by, and then we'll do a parentheses 1 minus parentheses 1 plus, and then 0.03 divided by 12, right arrow to get out from there. And then we need to raise up to the power with shift 6, and then I'm going to start parentheses negative 12 times 30 and close these parentheses, although it already gives you the answer, and you will round here down to 1264.81 to the nearest cent. So let's go back over here and put that in. So that will be 1264.81, and that's your monthly payment. So again with Desmos, notice how when I typed it in, it looks real similar to what I wrote down. And as long as you keep that in mind and do that, you will get the right answer on these. The calculation of this is, if I'm in face-to-face classes, these are the ones where I'm walking around the room and, a third of the class is having issues typing it in just because of parentheses and everything. So just be real careful with that. You got to be precise, and you'll get the right answer. Okay, so the next piece here, how much total will they pay for the house, including the down payment? So what we have to think of here is the total Well, they're going to get the $75,000 included in that total. They had to pay that right up front. They put that down. They didn't pay any interest on it, but they still paid that as part of the process of getting this home. And then they're going to have that $1,264.81 payment 12 months of the year for 30 years. So you just multiply that together, and this is, the total principal and interest, so to speak, that they would be paying. And when you add all those together, add those two terms together after the multiplication there on the second one, you get $530,331.60. So that's how much they really ended up paying for that $375,000 home. How much interest will they pay over the life of their loan? Well, anything they paid on top of the list price is interest. So we're going to take that total and subtract away the list price. And what you see here then is that they ended up paying $155,331.60 in interest, which, if you think about it, compared to the price of the loan, the cost of the loan, the amount they borrowed, it was $300,000. It's like 50% more than what they borrowed, more than that, just to be able to get the home now instead of in the future, however many years it would have taken them to save that on their own. So it's pretty ridiculous how much the banks get, and 3% is a really low rate, and these people are still ending up paying the bank over 30 years $155,331.60 for the privilege of getting the home earlier than normal. So keep that in mind as you are potentially out there in the real world buying a house on your own. Always keep in mind the interest. All right, so that pretty much takes us through, the questions you're going to see in the homework have similar concepts to what, I did in this example. And if you have questions about anything, please ask. That's the only way I'll know that you need help. And I will see you in cyberspace.